Okay, welcome. Today we're going to look at the domain of a function, and this is page 78 in your e-text, chapter 1. So let's go ahead and get our notes out and we'll get going. Remember, if you're falling behind taking notes or didn't quite understand something the first time, to stop the video to get your notes caught back up, or rewind the video and listen to it again. And if you still have questions, write them down on the side and we can answer them in class. Okay, let's go ahead and begin. This is the domain of a function. And the domain of a function is a set of all values of the independent variable for which the function is defined. If x is in the domain of f, f is said to be defined at x. If x is not in the domain of f, f is said to be undefined at x. Okay, so it talks about independent variables for which the function is defined. In our cases, or most cases of the functions we deal with, the independent variable is our x. So we're looking for the x's for which the function is defined. And usually that means all the x's when we graph that are actually on the graph. And sometimes when we're looking for a domain, it's easier to find where x is not in the domain. In other words, we're looking for where x is undefined. If we can identify that, then we can see where it is defined at, and we'll have our domain. So let's go ahead and take a look on how to do that. So we're going to look for, again, all the x's not in the domain, or where it's undefined. And we're going to think about that term undefined. What kinds of problems have we seen where values were undefined? Okay, so here's our example. We're going to start with a, and a is just a relation here. We have the point -3, 0, -1, 4, 0, 2, 2, 2, 4, -1. So we're looking for the independent variable, or in our case, x. So in this case, our x is -3, -1, 0, 2, and 4. So our domain of this function is just the set of numbers -3, -1, 0, 2, and 4. A domain is easy to find when you're given a finite set like this. You're just pointing at the x's. It gets a little more difficult as we move on to b, when we're given just an equation and we have to find them all, because I know there are infinite x's here. So let's kind of take a look at b. So if I write down what I have in b, I have the function g of x is equal to -3x squared plus 4x plus 5. And as I look at this, I'm using a little bit of logic. I see it's quadratic. I see my leading term is negative, and it's a quadratic again. So I know the graph without actually graphing it, but I know approximately what it's going to look like. So I'll draw my little thinking bubble here. We'll put in a graph. So we have this parabola. There we go. That is, because the leading term coefficient is negative, is facing upside down. So it's going to look something like this. Now, it's not a super accurate graph. I have no idea at this point, without doing more calculations, if it's in quadrant 2 or 3 or 4. But I know it opens down. It's something like this. Now, when I look at my x values, I can see that this graph, because remember, it extends on, keeps widening it out, or getting wider and wider, wider. The farther I go, the wider it gets. That means if I looked over here at negative infinity, I could trace a line down and it would hit the graph. That means the x coordinates on the left side are all on the graph. Same thing on the right side. If I go all the way out to infinity, looking at the x's and tracing down, they hit the graph. That means all these x's are in the on the graph as well. That means all these x's are in the domain. My domain goes from negative infinity to positive infinity. If I go back to the definition, I can see that there's no value of x I can plug in here and get undefined. Okay, let's move on to C so you can see what undefined looks like. Okay, so would be all the x's work. So my domain, again, starts at negative infinity and goes to positive infinity. Every number in between. If I look at C, I can see this is 1 over x plus 5. Okay, this is a rational function. I can figure out, or I have to remember, that I can never have division by 0. Division by 0 is undefined. So there exists an x that I can plug in here, add 5 to it, and I will get 0. And that x is outside our domain. So what I'm going to do is I'm going to take the x plus 5, the denominator. I'm going to set it equal to 0, and I'm going to see that, hey, x cannot equal 5. When I plug in 5, I get division by 0, so therefore x is not in the domain. It's undefined. Sorry, 5 is not in the domain. It's undefined. That means my domain are all the rest of the x's. So I can start over at negative infinity and take it all the way to 5, but not including 5. Unite that with the set of 5, but not including 5, all the way to positive infinity. And that is my domain for letter C. Okay, again, it's all about looking for where it's undefined. And the first case is division by 0. Then we have a case where radicals. Where's a radical equation undefined? Well, that would be trying to take the square root of a negative number. So we're going to figure out where part E, or where we are taking square root of a negative number. So if I'm given the function k of x is equal to the radical or the square root of 4 minus 3x, where is 4 minus 3x going to be less than 0? When is it going to be negative? So set it less than 0. With a quick solve, we can see that the values of x that make this negative will be all the x's, all I'm doing is solving my linear equation, that are less than positive 4/3, or all the x's that are less than 1 and 1/3. Okay, so what's my domain? These are the x's that make it undefined. So my domain are all the opposites. It's all the x's that are greater than 1/3. So this is my domain. So to write that, I would say, okay, less than means it actually can be 1/3. So my domain goes from 1/3 to infinity. Okay, so remember, these are the values that make it undefined. This is the actual domain. So what we did is we found an example where we looked at for the x's that aren't in the domain and used it to find the domain. So again, it's all about finding where functions are undefined. Division by 0, square root of a radical, there exists some values. And that's why if we jump back to B, that there are no values. I can't get division here by 0. I can't get the square root of a radical. That's why all the values work. Okay, I hope that helps a bit in finding the domain of a function. So if you have any questions, make sure you jot them down, and we'll take care of them in class.